Hello everyone, this is the first video of this C language course. In this video I will be explaining the structure of a basic C program, and then I will explain how a typical C program is compiled, what are the steps involved. So as you can see here, this is a simple program that prints some message on the output screen of machine. The message is hello world. There are a number of statements here. The first statement is basically hash include, then angle bracket stdio.h, then angle bracket close. The meaning of this line is basically to include, to copy some code from this .h file, from this file given into this particular file, into this .c file. This is one file and this is one file. I have referenced this file in this program. So in the pre-processing step, the code from this stdio.h file is included here. Why I need to write this syntax here? Because I have used this printf function here, and using this printf function I am telling the compiler to print this hello world message on the screen. Now in order to use this function, I also need to tell the compiler what this printf function is, what it do, how it do a particular task. So all this question, what, how, those are declared inside this .h file. This .h file contains the functionality of this printf function, the sequence of statements that are responsible for carrying out this printf function. So because of this we need to include this stdio.h file here. Then comes the main function. This is a function named main, and inside these curly braces we have the main function body. In C program, the execution starts from main function. The starting point is the main function, and from the main function we will be calling other functions also. Okay, like here the starting point is main function. From main function I will be calling printf function to print the output onto the screen. Okay, now we will see how it is processed. Basically, before actual compilation, pre-processing will take place, and in pre-processing three things happen. Inclusion of some code, macro expansion, and conditional compilation. I will explain these in this video in some time. Okay, and then apart from these three things, okay, like these are comments. In order to write something like documentation, here if I write here is the code. Okay, for a user reference only I have written these lines, that is here include this. This syntax is to include standard library information for someone who is reading this course or reading this code. So for him this is a documentation type thing. It tells him that what this line means, but for the machine this is nothing. Okay, it serves no purpose. So in pre-processing task, this thing is replaced by space. Okay, this whole code will be replaced by space because it is of no use to the machine. Okay, so this is what comments are replaced with single space. Okay, now the when a line precedes with this pound or hash type symbol, we call these preprocessive directives. Preprocessive directives. So these tell the compiler that before actual compilation, being a preprocessive directive, during the preprocessing step, carry out the procedures related to these preprocessive directives. Okay. Now, I have written here 3 things: inclusion of header files or user-defined files, macro extension, conditional compilation. Now, first one is the inclusion of header files. I have already told that this is a preprocessive directive, and this includes code for this .h, stdio.h file in our code. Stdio means standard input output header file. Okay, stdio, here you can see stdio.h contains declaration of functions like printf, scanf, getchar, open, close, etc. These are different functions that achieve different tasks. So stdio.h contains declaration of these functions. Declaration basically means I am telling the compiler what this function will achieve, what input will it take, what return value it will return. So all these functions are declared in this header file, and before using that function, we need to tell the compiler what this function is actually about. We need to tell its declaration. Like, it's a simple thing. When you have to do some project with someone, first we need to introduce each other. Okay, only then we will be once you know each other, okay, basic intro, then you will be doing or achieving a particular project, doing some work for a particular project. Okay, but first introduction is important. So this is what this hash include do for printf function. It introduces to the compiler what printf function is all about. And then after this, there are 2 things. We can include header files or we can include user-defined files. Now this is a user-defined file .c. I have written this code by myself. User have written this code. But if I need to include this code in another source file, okay, so like this is my .1.c file, and what if I want to include this code in some other file? Why to include, why not to write? I can write also, but why to write it again and again when I have the syntax to include it in another file? So how I do that? So this is the syntax: hash include, and this double quotes, then I will give this. Now dot save it. Okay, so with this syntax, what will happen when this file is compiled? So code of this whole file is included here. Okay, see, I have run this file, not this, but now during preprocessing step, the code for this file has been included in this. So when I compile this code is already present here. So this will print hello world. So I can include either header files or source files. Now, what is the difference between header files and source files. This is a notation that header files only contains declarations. That is, I'm telling the compiler what is the type and name of a particular thing. I'm not telling it what task it do or what are the statements that it includes. I'm just telling the type and name thing. So as a notation, those things are done in header files, and what are the statements for a particular thing, the definition of a particular thing, those things are included in source file. So this is basically a minor difference between these two files, header file and source file. Now the next one is basically the macro expansion. Before compilation, macro expansion also happens if macros are present in our file. Now how to declare a macro? We declare it by using hash define. This tells that I'm writing a preprocessing directive, then we use this keyword define, and after that define, you can here see define. I am telling that to the compiler that limit means 5. Wherever you encounter limit in the code, replace it with 5. Okay, so here when the compiler does preprocessing on this code, int value equal to limit, okay, this limit will be replaced by 5. This is basically a variable. We will be discussing this in future videos, but just for the moment, understand that this is basically a container named value, and inside this value I have stored limit. Limit means 5, so 5 is stored in this container. Okay, when this conversion takes place during the preprocessing step. So this is another thing. Here I have defined that if I write something like this, sum a b, that means replace this thing with a plus b. So here I have written, I am printing sum 8, 9. So this will be replaced by this 8 plus 9. Okay, this code will be 8 plus 9, and during the compilation step, this will be treated as addition. Okay, but during the preprocessing step, simply what is happening, this sum ab is being replaced with this. So this will be replaced by this 8 plus 9. This thing will be replaced by this. No. When all these steps have been completed, that is inclusion of header file, macro expansion, replacement of comments, and all other things, we have a expanded source code. Okay, expanded source code, how? Like, expanded means instead of this line, whole code is present here. So now instead of this one line, I have whole code for another file. This is the expanded source code. So now expanded source code is there, and this expanded source code will be compiled by the C compiler. This will be converted into some file known as object file. So for each of this .c file, we will be having a object file. Okay, and just know that when I have a program and the program is written across different files, like there is a program to achieve a particular task, and the code for that program is written across four .c files, 4 source files. So I am having 4 object files after this compilation. So in order for the program to run in memory, these 4 object files should be combined, and how these are combined? Linker will take these object files and will resolve the references among these files, and a .exe file is created. This .exe file is what we run on our machine. Okay, this is my, when I try to run this, a .exe file is generated here, untitled .exe. This .exe file runs in my memory and the message will be printed.